All right, our next presenter is Elly Perez. All right, so what Christina is to sea turtles, I would say Elly is to coral reefs. If you've been here all day, you might know what that means, but Elly became a scientific diver in undergrad and has sort of been hooked on coral reefs ever since. That love has taken her all over the world to study coral reefs, and she really values work that brings together conservation of those ecosystems along with communities. So this capstone project is right in line with that work that she values so much, and I'm excited for you to hear about Elly's work for her capstone project. Welcome, Elly.
In 2022, I moved to the island of Saipan, a small island in the Western Pacific Ocean. My job focused on strengthening the local capacity to respond to coral reef disturbances. I spent many of my days in the shallow lagoons, bouncing from one site to the next, swimming transects, taking photos, observing. I was looking for signs of stress, changes in color that could signal the early stages of coral bleaching. Coral bleaching is primarily caused by unusually warm ocean temperatures linked to global climate change. When corals are stressed, they expel the algae living in their tissues. Without this algae, the coral turns white, and if conditions don't quickly improve, bleaching often leads to death. Because the root cause of coral bleaching is global, responding to bleaching at a local level presents a major challenge for communities who have limited influence over global climate change. That tension between local action and global causes was at the heart of my work in Saipan. It was a question people ask me a lot, and one that sticks with me still. When the problem is global, can local action still make a difference? The number of coral bleaching events has risen dramatically since the 1980s. Bleaching is not only more frequent, it's also more intense. And while a stressed reef can't scream for help, it does communicate. Over time, it tells its story through shifts in color, changes in structure, the disappearance of familiar species, and the persistence of others. My project is about listening to those quiet signals. What can they tell us about how to better support these ecosystems? And how can that guide what we do next? And while this story isn't about the reefs of Saipan, the work I did there is deeply connected to what I'm doing now. On another island, about 1,000 miles to the southeast, the island of Pohnpei. Pohnpei is one of hundreds of islands that make up the Federated States of Micronesia, a sovereign island nation in the Western Pacific. In Pohnpei, coral reefs are deeply woven into daily life, culture, and identity. For generations, communities in Pohnpei have been guided by a strong tradition of marine stewardship that continues to shape local reef management today. And these efforts are strongest when they're backed by locally relevant data. Most of the data available today focuses on global trends, and while those trends are important, they often lack the resolution needed to guide decisions at a local level. And if management is ever going to be successful, communities need to know more about what's happening specifically on their reefs. Pohnpei's coral reefs have been experiencing unprecedented amounts of bleaching events. Over the past decade, the island has gone from recording no mass bleaching to experiencing 3 major events, most recently in November 2024. This most recent event became the focus of my project. I wanted to uncover site-specific insights that communities in Pohnpei could actually use to support the work they're already doing. To do this, I explored 3 main questions. which corals or reef areas held up best during this event, what local conditions help some reefs do better than others, and how can this information help communities protect reefs in a changing climate. This analysis builds on over a decade of long-term monitoring around Pohnpei. In November 2024, during the peak of the major bleaching event, local field teams surveyed 24 sites across the island. They had all this new data, but no one to process, analyze, and interpret it. This is where I come in. They collected nearly 6,000 underwater images, which meant I had nearly 6,000 underwater images to analyze. I used an online tool that helps classify benthic organisms called CoralNet. You can see me in action here. I identified corals and then categorized them by bleaching severity. Once the photos were processed, I used a statistical program called R to do my analysis. I started digging into bleaching patterns. Which species were less affected? Which reef sites held up better? I also brought in long-term monitoring data to explore how past events might have shaped what we're seeing now. All of this analysis helped me connect the dots between what's in the data and what that could actually mean for decisions on the ground. The Conservation Society of Pohnpei plays a leading role in supporting community-based reef management across the island. We worked together to make sure this project produced something of value to them. So for the final step of my project, I turned my results into something useful, a set of clear, actionable recommendations, something they can use to talk with communities and local leaders about what's happening on their reefs and what can be done to help. I'm looking forward to continuing this work as I'll be heading to Pohnpei this summer to share those findings with local managers. To give you a better sense of what these patterns actually look like, I want to zoom in to one site called Nan Wakil. This site emerged as one of the most resilient sites, and I'm going to explain what makes it special. This graph shows coral species abundance at this site. Each bar represents a different species, and the height of the bar represents its abundance at this site. The colors on the bar chart represent bleaching severity. Light blue shows you the percentage of healthy corals, and for this presentation, just know that the medium and dark blue together represent the corals that were affected by bleaching. So as you can see, across all coral groups, this site showed consistently high proportions of unbleached corals. That kind of across-the-board resistance suggests there may be environmental or biological factors buffering this reef from heat stress. Next, I want to show you what reef recovery can actually look like, how a site can go through major bleaching and still find a new kind of balance. This is the site in 2012, before back-to-back bleaching events in 2016 and 2017. The colors on the pie chart represent different species, and the size of the slices represent their abundance. Here is the same site in 2018 after bleaching. You can see that some coral groups have disappeared. And now you can see charts from 2024 and 2025, and they look very similar to 2018. The coral community has changed, but it's stable. And that's a key point I want to make here. Change doesn't always mean collapse. Sometimes that change is what actually helps a reef survive. And what makes this site stand out even more is there's not one group taking over. And that diversity really matters. When a reef has a lot of different coral species, it's more likely that some will survive and help a reef recover. Think of it like ecological insurance. If one species is hit hard, others can step in to maintain ecosystem function. So when you put all of this together, low bleaching, stable coral communities, and strong species diversity, it starts to look like this site might be functioning as a natural refuge, meaning that this reef might hold up better as conditions get tougher. I'm sharing this story because it's a great example of how we can use site-level data to guide real decisions. When we zoom in like this, we start to see opportunities, not just problems. So based on the insights I've shared, here are a few opportunities for action. First, we can prioritize this site for increased protection. It's holding up better under stress and still supporting a mix of coral types, making it a strong candidate for conservation attention. Second, we need to understand why it's doing well. Fine-scale environmental monitoring could help uncover what's driving this resistance, and those insights can inform actions in other places. And third, use this site to guide restoration. Some of the most vulnerable coral species here are showing resistance, which suggests it could be a good spot for outplanting or other targeted recovery efforts. Today, I only had time to share the story of Nan Mokil. But behind the scenes, my project brought together the stories of 23 other reef sites across Pohnpei, each one facing different challenges, each one teaching us something different about how we can help on a local scale. This project was only possible because of long-term monitoring efforts in Pohnpei. Every insight I've found comes from years of consistent data collection by local teams. So if there's one message I want to emphasize, it's this: long-term monitoring and local leadership are essential. Global narratives portrayed in the media can make it feel like coral reefs everywhere are doomed. But local long-term monitoring helps us tell a different story. Yes, it's a story that includes loss, but it's also a story of resistance, adaptation, and survival. That's the story my project helped to tell. It showed that even under intense, repeated stress, some reefs are resisting bleaching. Some coral communities are shifting in ways that demonstrate adaptation, and some vulnerable species persist in places where we didn't expect them to. So I come back to the question I asked you earlier. When the problem is global, can local action still make a difference? I believe it can, and projects like this one give us reason to believe it can. If we use science not to just describe loss, but to guide action, and if we continue to invest in local monitoring and follow the lead of those who know these reefs best. That's how local action goes from simply responding to climate change to actually shaping how our reefs survive it. And that's where our focus should be. Thank you. Questions?
You crushed it, by the way. Does the outline of this island have anything to do with the success rate of recovery?
Like
all the island, the like reef on the outer edge, and the coral inside that little outline, does it have anything to do with the success rate of recovery? Like it's like blocked off? Like,
Sorry.
When you're looking at a map of this island, yeah, and you see that little outline of land.
I understand what you mean now. So that's actually that's kind of how we describe what's an inner reef and what's an outer reef. And actually from my findings, we found that inner reefs actually are resisting bleaching more than outer reefs pretty consistently. There are a few outer reef sites that we found that were doing good, and they actually were near channels. So we're thinking maybe it has something to do with water flow in those areas. But in general, the inner reefs do seem to do a little bit better with bleaching.
Thanks so much for that presentation, Elly. I really loved seeing the pie charts in particular that so clearly made the case for changing the representation and the makeup of reefs, but stabilizing, through that third bleaching event. It was really, really so clear. So thanks for that storytelling. I wondered, were there any patterns in your findings that surprised you or got you super excited?
Yeah. So there's a species called a cropra. They're like a branching coral, and they're usually pretty vulnerable to bleaching. They're the first to die. But they're also usually the first to grow back. They grow really, really quick, and they're really important. And the bleaching was pretty bad for that species, kind of across the island. But there was kind of this weird little subsect of them on the inner reef sites, so the sites that were like inside of this line around the island. And it was all on this like other side of the island. So all the humans are kind of up there in this corner. And there was some like 4 inner reef sites down on this side that happened to have small populations of these branching corals that were surviving. So I thought that was super interesting. They were small populations, but they are resisting bleaching better than the other areas. So I'm super excited to like dig into that, whether maybe it's environmental or is it like actually something genetic in them. So yeah, that was probably the most surprising to me.
Great, thank you. And then we have a committee question on YouTube. How can we scale this up to island and region?
Yeah, so we can scale it up in a multitude of ways, but if we dig more into, which I'm going to be working at the University of Guam after this, to dig more into the patterns of resistance. So this project kind of was just a foundation about where is resistance happening, what does it look like, and then hopefully we're going to be digging more into like why it's actually like why the reefs are resisting. So once we do that type of research, we can scale that up to other islands, and especially in Micronesia that might have similar patterns as to like why inner reefs are doing better, why the reefs near channels are doing better, and then you can apply those strategies to other islands.
Thanks so much, Elly. Great presentation.